So we're going to use the MGF to determine whether x plus 2y is Poisson if both x and y's are i.i.d. Poisson lambda. So there are several ways of attacking this problem. Let's start by defining a w being equal to x plus 2y, and we have then in that case, if w is Poisson, then the expected value of w, which would be expected value of w, is equal to expected value of x plus 2y. By linearity, we get expectation over x plus 2y. Now, because x and y are lambdas, this adds to 2 lambda, which would be 3 lambda. So this should be the expectation of w, if w is Poisson. But let's use the MGF now to determine whether this actually holds. So let's start by calculating the MGF of w and then compare it with a Poisson that is actually 3 lambda. So we're asking whether this following thing, question mark, is true. All right. So the MGF of w in this case, a function of t, that's the same thing as the expectation by definition of the exponential t w. That's just the definition. Now we substitute in x plus 2y and just use the rules of exponentials. So multiply that in, and then t to y like this. Now we use i.i.d. that x and given that x and y are i.i.d. So we're going to use this fact. Then in that case, we can separate out the expectations like so. Now, we can calculate these two separately and just multiply it. Alright, so let's start with this guy here. So the expected value, and now we're going to use the definition of the Poisson expectation. So we then sum over from little x, whoops, it should be starting from 0, over its support. Now we also use lotus, like so. This should be a little x here, just to make sure. And then we use the definition of the probability mass function of the Poisson. Right, so we are now using for x, we're going to go back and collect lambda here, just to remind ourselves. So this should be lambda power to x, and then we have the exponential minus lambda. Okay, So this is just the PMF of Poisson, and this is through Lotus, a transformation of X. Okay. Now let's move on. So what do we do here? This looks a little complicated, but we can notice that we can move out. This exponential doesn't depend on X. So let's start by doing that. So we get exponential minus lambda, the sum over x0 to infinity, and we have x like that. And then notice also that we have e to the x, tx, so that's power x, and there's a lambda power x. So we can just move out that x the following way. All right. And now we can use Taylor series to say that this is the exponential to the following term here. So minus e to the e to the t lambda, which is equal to, just to simplify this a little bit, minus lambda plus e t lambda, right? And that is just minus lambda 1 plus e to the t. So now we have the MGF for this term here. Let's do the same thing, calculating what the MGF for that term is. And that should be, I'll do that. E. So it's the same calculation, but we have, the only difference is that we have multiply by 2 here. So we can go over the whole calculation again, or we just notice, let's just write it out first. T, 2t y, and we could just do the whole thing. We'll be arriving at a fairly similar term, or we realize that it's actually e to the t here, so the only difference that will be happening is that we get e to the 2t here instead. Okay, so it'll be e minus lambda, and then we have plus lambda e to the 2t. Right? Now we can go back here and insert what we've got. So let's copy this guy, put him here, like that, and let's copy that, like this. Now this looks really ugly, right? So let's just do the following. We'll move it. It's getting a little bit tight up there, so we continue down here. So this equality continues down here. Let's move down this whole thing. Duplicate it, move it down here, and let's simplify this a little bit. So we have e to the minus lambda 1 plus e to the t, and then we have another addition here, plus Let's just also factorize this. So we get lambda minus 1 plus lambda e to the 2t, like that. Okay. I realize I did one little error here. Let's go back. This here should be, obviously, the minus sign should stay inside here. So we have the following. Let me remove this minus here. It should be minus 1, like that. Yep. Minus like that. We have the same error here. Minus like this. Okay. Yeah, and this looks okay, right? All right. Sorry about that. Those minuses tend to be easy to forget. So let's continue ahead with this expression here. What we get is e to the, well, let's see, this needs to be corrected as well. Like this. All right, this looks okay. And now we factorize out this last lambdas like this, and we get e to the t minus 2. Those 2's are coming from this minus and that minus. And then we have, well, look at this. This is another error. This lambda should be there. Okay. And we get the e to the 2t. Okay. And we notice now, we will ask whether this expression here equals an expression where the Poisson MGF for 3 lambda is equal to that. And by doing the same calculation, we see that if W was 3 lambda, it would have, and we go through the same calculations here, basically this one here, we see that if MGF of a Poisson, well, let's call it Z, if Z now was distributed Poisson 3 lambda, that has a MGF of e to the 3 lambdas times e to the t minus 1. And comparing these two, we see that W is not, in fact, Poisson 3 lambda.